Let's look at this example. The privacy is a concern for many users on the internet. Our survey shows that 59% of internet users are somewhat concerned about the confidentiality of their email. Based on this information, what is the probability that from a random sample of 10 internet users, 6 are concerned about their privacy? So, when we choose a sample of 10 individuals, we assume that they are independent of each other. So that makes an example of 10 trials. And the success here will be whether they are concerned with the privacy or not. So this is a binomial distribution problem. What will be considered the number of trials? What is n here, the number of trials? 10. And what is the probability of success? 59%, 0.59. So the question here is, what is the probability that for a random sample of 10 internet users, 6 are concerned about the privacy of their emails? So we can use our calculator. Here we have x 10, 0.59. And we want to find the probability that x equals. So you can use a Google calculator. Binomial distribution calculator. Here, the probability of success is 0.59. The number of trial is 10. And we want 6 success. So this is the probability that of 10 randomly selected individuals, 6 of them are concerned with their privacy, given that 59% of the population are concerned with their privacy. So the Google calculator can give us more than just the answer of x equals to 6, which is 0.025. It can tell us the probability that less than 6 of the 10 are concerned about their privacy. The next one is, it can give us the probability that 6 or less are concerned with their privacy. So we want to make the difference between these two questions. Here is less than 6. Here is at most 6 or less. Here is greater than 6, and here is greater than or equals to 6. If you were to use your TI-ATT calculator, the TI-ATT calculator only gives you either this or this. This is binomial CDF, and here is binomial PDF on the Google calculator. You get to this by doing second function distribution. Second function distribution. You can do second function distribution is under VARS. And then you will choose binomial PDF. And you will have 10, 0.56, and 6. Binomial PDF. In some calculator, they might ask you what is the number of trials, what is the probability of success, and what is X. Let's look at another problem. So in some cases, you will want to find the cumulative distribution. Cumulative distribution is, for example, if I wanted to know what is the probability that 6 or less, or at most 6 are concerned with their privacy, then you will do X less than or equal. This is the cumulative distribution. You can use your calculator. You can use the table at the back of your book. But the table of the back of your book is limited to some type of probability like 0.1, 0.05, 0.15, 0.2. A probability that 0.59 is not there, or 0.33 is not there. And the number of trials that you can get there, the maximum is 20. So I will encourage you to use either the binomial calculator from Google or your TI-83 calculator. So when you are using the table at the back of the book, just for completion, so that you know what you are supposed to do, you have a table with the number of trials on the side here, and within each number of trials, the possible number of success and the probability of success are aligned on the first row here. So matching the number of success with the probability of success for that number of trial, you get the probability distribution. And if you want cumulative, you add everything to where you are. In some cases, the complement rule will become useful. If you have, for example, 6 trials and you want the probability that the number of success is greater than 4, it's better to do the cumulative for 4 and subtract it from 1 to get 4 greater than 4. Let's look at this example. A biologist is studying a new hybrid tomato. It is known that the seed of this hybrid tomato have a probability of 0.7 of germinating. The biologist plants 6 seeds. What is the probability that exactly 4 seeds will germinate? Exactly 4. So I can use the Google calculator. The probability of success was 0.7. The number of trials, 6. And then the number of success is 4. So once I do this, I will identify the question that I have. So this question was about exactly 4. So the answer is 0.32, exactly 4. If the question was less than 4, we will have this 0.25. If the question was less than or equal to 4, 0.57. Greater than 4, 0.42. If you are using your TI-83, 84 calculator, you will do second function, distribution, and choose binomial PDF for equal to. But if the question was like the next question, what is the probability that at least 4 seeds will germinate? At least 4 seeds will germinate. At least 4 is for greater than or equal to 4. So you can either use the opposite, less than or equals to 3, to use the cumulative from your calculator, or you use the Google calculator. We have here is 0.74. Let's look at the Google calculator. This is greater than or equals to 4. This is 0.74. We learned how to find a mean, the variance, and standard deviation. Mean was NP. Variance was NPQ. Q is 1 minus P. And standard deviation is square root of the variance. What I want us to look at today is the Kotter problems. The Kotter problem is used to determine the minimum number of trials to achieve a certain number of success. For example, you are a biologist. Let's look at the example we had. And you want to get at least 4 seeds germinating. So the question in the Kotter problem is to find the number of trials so as to achieve a certain number of success. Kotter problem. What is the number What is the minimum number of seeds? Assume seeds are expensive and you need at least 4 to germinate for your work. What is the minimum number of seeds you should purchase to be 95% sure that at least 4 of them is going to germinate? So what is the minimum number? What is the minimum number of trials to be, let's say, 95% confident that at least will be successful? In other words, what is the probability? What is the minimum number of trials so that the probability that x is greater than or equals to 4 is more than 0.95? So now we don't know the number of trials. If we want to find the probability that x is greater than or equals to 4, we are going to go from 4 and not knowing where we are going to stop. To resolve this, we can decide to use the complement rule. With the complement rule, the probability that x is greater than or equals to 4 is the same thing as the probability that x is less than 4. which is 1 minus 0.95 is greater than or equals to. I want you to know that probability that x is less than 4 is the same thing as probability that x is less than or equals to 3. So that means 0.05 is greater than or equals to probability that x is less than 4, which is the same as that x is less than or equals to 2. And now we will be trying an error. We will start with, we know the probability of success here is 0.7. And we want the cumulative distribution at 3, or the probability that x is less than 4 is the same thing. Let's look at so if we have 6 trials, what is the probability that x is less than 4? If we have 6 trials, what is the probability that x is less than 4? This is the probability that x is less than 4, right? Okay, now I want you to remember that what we are looking for is the value of n for which the probability that x is less than 4 is less than 0.05. That is our quota problem. What is n? So that the probability that x is less than 0.0. This is what is here that I have reproduced. Let's have that in mind. We are looking for n so that this probability is less than or equal to 5. How many seeds should we buy to be 95% sure that at least 4 of them will germinate? Now, it's easier to do this problem using the Google calculator than the TI-83, just because with the TI-83, you will be changing the number of trials. So we are going to change the number of trials now to when it does not work because the probability is bigger than what we need, we will increase the sample size. So I will make it now 10. Does it work at 10? Probability that x is less than 4. Is it less than 0.05? I want everybody to check. Is it less than 0.05? And what is it? What is the probability that x is less than 4? 0.01. 0.01. So we are going to change 10. We will lower it. When it works, we will lower the minimum. Let's try. It didn't work for 6. And it works for 10. Let's try 8. Does it work for 8? Is this number less than 0.05? Is it less than 0.05? It is not less than 0.05 because it's 0.057. So we are going to change it. What do you think? What can you suggest we change it to? 6, it did not work. 10 worked, we are not sure it's the minimum. 8 does not work. What should we try? Try 9, because we are looking for the minimum number of trials. We don't want to buy more seed than what we need. Does 9 work? 9 is working. So 9 is the minimum number of trials for us to be 95% sure that at least 4 of them are going to germinate. There are many situations in which we might be thinking about this. For example, in the past, when you go to the store and buy eggs, you were not sure that all the eggs are good, you know that? So you might want to buy more than what you need for maybe you are cooking. But you don't want to buy too much more than what you need. You can use the quota problem to say, what is the minimum number of eggs I should purchase to be 95 or 99% confident that at least 3 of them, at least 20 of them, at least 1 of them is going to be a good one. And you use the quota problem. Essentially, what we are doing with the quota problem is that we are reversing the problem. If we want at least 5, we will do less than or equal to 5. And if we want 90%, we will compare the reverse to 10% instead of 90%. So essentially, when you want it to be at least 4, you will change it to probability that x is at most 3 is less than or equal to 1 minus the confidence you have. X less than 4 is the same as x less than or equal to 3. This is the last part of chapter 5. Moving to chapter 6. This course can be compared to a normal distribution that we are going to learn now. We started, it was very easy. Chapter 1 was very, very easy, right? So, and we started growing. Chapter 4 is the most difficult one. Chapter 5, 6, we will be going down level of difficulty. So we call a distribution normal if the curve of that distribution has the following property. The curve is the shape, and the shape is like a bell. From calculus, you should remember if you did calculus that you do curve, the curve of a function. So if you have a function and the curve is like this, then it's a bell shape. So then we also expect the mean to be actually at the middle. The mean will be. Because it's at the middle, it is again the median because it's at the middle. It is dividing the curve into 2 equal parts of same shape. So we say it is symmetric. It is symmetric. It is symmetric with respect to the mean. Bell shape, symmetric with respect to the mean. The mean, the mode, and the median are the same. And it satisfies what we will call the empirical rule. The empirical rule is more accurate than the Chebyshev because the Chebyshev gave us the minimum proportion of values that are within a certain distance from the mean. So we are going to make 1 standard deviation, 2 standard deviation, 3 standard deviation. This is not looking very nice. So this is 1 standard deviation, 2 standard deviation, 3 standard deviation, minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. We call this the empirical rule, 34%. 13.5%, 2.35, 13.5%. This is the empirical rule. For example, suppose a distribution has a mean of 600 and a standard deviation of 100. Then at the level of the mean here, we will have 600. After 1 standard deviation, what should be the number I put here? $700, $800, $900, $500, $400, $300. So if I ask you the question, using the empirical rule, what is the probability that a value will be between 600 and 700? Using the empirical rule, what is the probability that a value will be between 600 and 700? Using this rule, what is the proportion of value that is within 1 standard deviation to the right, between 600 and 700? Pardon? 34%. 34%. What about between 700 and 800? Pardon? 13.5. What about the proportion of values that are above 800? Above 800. This is a little tricky now. Okay, I want you to observe that the mean is dividing this distribution into 2 equal parts. So the probability to be to the left is 50%, to be to the right is 50%. 1 standard deviation, 2 standard deviation, 3 standard deviation. So here is 2.35. What do you think will be anything above the 3rd standard deviation? If all of this side is 50%, this is 2.35. Here is 34, 19.5. What will be anything above the 3rd standard deviation? Pardon? 0.15%. 0.15%. So if I add now, here we are at 700, 800, 900. Now above 800, what will be the proportion above 800? 2.5, not 2.35. 2.35 is between 800 and 900. We no more have divisions after the 3rd standard deviation. Okay. That is the empirical rule. What about between 400 and 500? This is 34. So if I ask you any question, just count the number of standard deviation you are moving away from. So the empirical rule has the disadvantage that we can only answer question when it is an integral addition or integral subtraction, like 2, 3, 4 standard deviation from the mean. So we are now going to move further with the standard normal distribution. Standard units and area under the standard normal distribution. Let x be a random variable with mean mu and standard deviation sigma. Then z equal to x minus mu over sigma is called the standard score. Of x. If x is a normal distribution, z is called the standard normal distribution. It has mean d of z equal to 0, a standard deviation sigma z equals to 1. I'm going to explain that here. X is a random variable with mean mu and standard deviation sigma. We can standardize x as z equal to x minus mu over sigma. I can write this again as 1 over sigma x minus mu. So I will think about this z as a linear transformation ax plus b, where a is equal to 1 over sigma and b is minus mu over sigma. You don't need to write this, I'm just explaining so that you understand why we say that the mean is 0 and the standard deviation is 1. So the mean will be, we say mean of a linear transformation is anything in front of x times the mean of x minus mu of x. And the mean of x is the same as mu. And the variance of z We were squaring the number in front of x. So we square this number and multiply by the variance of x. This sigma square. This sigma square. This is equal. So we are saying that if x is a normal distribution, then z is a normal distribution called the standard normal distribution, which means 0 standard deviation. So with a standard normal distribution, we now can view empirical room with numbers zero, one, minus one. Because sigma equals to 1. Let's look at an example. In this example, the pizza power franchise specifies that the average amount of cheese on a large pizza should be 8 ounces, and the standard deviation only 0.5 ounces. What does this mean? That when you buy your pizza, with a standard deviation of 0.5 ounce, the average amount of cheese is 8 ounces. So we are here 8. The standard deviation is 0.5. What should I put here? 8.5. 9. So 34. I want you to observe that within one standard deviation, we have 68%. Within two standard deviations, we have 95%. Within three standard deviations, we have 99.7%. There is 0.3% that is shared between the two tables we observed. So about 68% of people will get their cheese average between 7.5 and 8. About 95% will get their own cheese between 7 and 9. 99% will get between 6.5 and 9. The same thing when we hear about the average consumption of gas from a car. It can be advertised that the average mileage per gallon is 28. You need to know the standard deviation. Because if the standard deviation is 2, then you can get 28 minus 6, 22. You can get 22. If the standard deviation is 2, you can get 34. So you will get between 22 and 34. So the question will be, if you have your car, if you buy pizza from this franchise, and you are able to calculate the amount of pizza which is in it, you can determine if you were cheated or not. Okay? So the government will only consider that you were cheated if the average, not the average, now it's your pizza that you want. If the quantity of cheese on your pizza is less than 6.5. you will say that you really made it if you like it, cheese anyway, if it is more than 9. So in this example, an inspector is going to come at random and pick a pizza and then calculate the quantity of cheese on that pizza to know if they are not actually cheating it. So what is that quantity? 6.9. He comes and finds that that 6.9 is within 3 standard deviations. So no problem. Okay. You go to court, they will say, yeah, we are sorry for you, but you are still within acceptable range. We could also use the standard normal distribution by finding the standard score of the amount of pizza that you have. The standard score tells us how many standard deviations you are moved away from the mean. So Z will be 6.9 minus 8 divided by 0.5, which is negative 1.2. So you are within 3 standard deviation, that is between -3 and 3. I'm forgetting to write on the whiteboard. Actually, it's like difficult to write on the whiteboard than to write on this whiteboard. When I'm using this pen, it is a little. So we can use either the empirical rule or the z-score to answer this question. Using the empirical rule, this is 8, 7.5, sorry, 8.5, 9. Eight, 7.5, 7. Or we do C equals to 6.9 minus 8 over 0. So which is within 3 standard deviation. The standard score is more useful than this, especially for those who don't have a calculator. If you want to do your problems manually, the standard score will become very useful. So the standard score is obtained by using the mean and the standard deviation from a raw score X. Now, if you have the z-score, you can solve for the raw score X. So X is equal to sigma z. In some problem, you are asked to find the raw score giving the z-score. We are going to learn how to use TI-83 calculator to get these values. So now we are going to work on finding the probability that a z-score is within a certain range. So the standard distribution that you have only gives you the cumulative distribution. The cumulative distribution is f of x equals to probability. Let me put a. F of a equals to probability that z is less than or equal to a. So if this number is a, the cumulative distribution gives you this area. So if you want to find the probability that A is less than or equals to Z, less than or equals to B. It is the probability that Z is less than or equal to B minus probability that Z is less than or equal. This probability is this left area. Suppose I have B here, and I want the area between A and B. I want the area between A and B. Now I can only know the left area, which is the probability that Z is less than or equals to. So then I will take the area to the left of B, that is all of this, minus the area to the left of A. Okay. If you have TR 83, you don't really need to understand this because we are going to use it. But I want you to know how to use the table. So we are going to find some example. We will start with the probability that Z is less than or equal to -1. Then we will do probability that Z is less than or equal to -1.24. We will do the probability that Z is less than or equal to 1.5. We will do the probability that -1 is less than or equal to, that is use -1.3, or is less than or equal to Z, less than or equal to 1.16. So I want us to use the calculator, and I will also show you the table on the board. What we will be doing is using the table, using the calculator and confirming the result on the table. So this is how the table is. So this table, the first column here is the first decimal of the Z. This table is for the cumulative distribution at a given Z. So the first decimal of the Z is on the first column. When you match it with the second decimal, which is one of these numbers at the top here, you get the probability that Z is less than that number. For example, Z is less than or equals to 1, to -1. Z is less than or equals to -1. I'm going to look for -1. I know up here because I cannot show the whole table. So at the top here is 0, 1, 2, 3, 4, 5, 6. I will count the column. So now I go to -1. -1 is here. And -1 is -1.00. So we are here. You see the number I'm trying to point at, okay? Can somebody read it? Thank you. That is 0.1566. Let's use the calculator now. If you have your calculator. You don't have your calculator? Do you want to use Excel? If you like, you use Excel or you use calculator, but Excel is not so different from the table, but it's better than the table. You don't suffer as much, but you will still have some calculation to make if you're using it. So let's use Excel. I am using Excel. You are using calculator. If you want to use Excel, you use, but let's learn calculator first. Calculator, you go to second function, distribution, just like we did for binomial. Second function, distribution. You will choose the second one, normal CDF. So to use Excel, I will have some trouble here because I can just tell you instead of struggling this way. You type equal to, and then you begin to type, that is my equal to, you see what? Normal, N-O-R, and you will see, yes. Use standard, you see S, normal. Anybody else is using Excel? I will make it in a way that we can use Excel at the same time. So with your calculator is different. The easiest one, you will have lower value, upper value, mean, and standard deviation. By default, your mean is 0 and the standard deviation is 1. That is for the standard normal distribution. So when you are there, we are starting with this. Let's agree, we start with this one. When you are doing this, the lower value here, the upper value is -1. The lower value is negative infinity. So write -1000 for that. Because you cannot type negative infinity. And we know that we have almost everything at -3. I could say use -10 and it will work. Even if you use anything negative, when you say -1000, is 1000 standard deviation below. You are not getting anything there. So we will consider that as our negative infinity. So you will type -1000 for lower value, -1 for upper value, and press equals. You should get the answer. Some of your calculator will open a bracket. If you open a bracket for the standard normal distribution, you will have normal CDF, open the bracket, -1000, -1. Because by default, the mean is 0. The standard deviation is 1. If you are having a bracket open, just put the lower and the upper value. It will give you the area between the two values. For those who have, anybody has a calculator that open a bracket? Nobody? Yours open a bracket. It didn't say lower, upper. Okay, if you open bracket, this is what you should use. Yours say lower, upper? Okay, good. So now, let's use Excel. In Excel, you type equal to and begin to type normal. So we are going to use normal S for standard. If you use normal distribution, the only difference is that you will put the mean to be 0 and the standard deviation to be 1. But if you use normal standard, look at what will happen. They will always tell you what to write. Here is -1, comma, and it will say cumulative true. Close this bracket, and you will have the answer. Excel will only give you the left area. Excel gives you the left area. If you want the right way, okay, let's change it to greater than or equal to. I want to think that we should know how to use it. Let's change it to greater than or equal to. So greater than or equal to, I am changing to -1.24. So -1.2 is the lower value here. You want greater than -1.24. That means you start from -1.24 and go up. Okay. The upper value, we will put 1000. for those who are using a calculator. So go from negative 1.24 is the lower value, and the upper value is 1,000. Now, using the table, 1 minute we will use the table. I want you to know that Z greater than A is equal to probability that Z is less than negative A. Probability that Z is greater than A is the same as probability that Z is less than negative A. So I'm going to use that. You don't need to do that because your calculator have lower, upper, you don't have that trouble. So, but if you are using the standard table, which is this one, and I want to find the probability that Z is greater than negative 1.24, I'm going to look for probability that Z is less than 1.24. So I will go to 1.24. This is 1. 1.2 is here. 0, 1, 2, 3, 4. So what do you get from your calculator for those using calculator? When 8925, what we have here with greater, with less than. Everything on the table is fixed. It cannot be changed. So all the table is about less than, less than. So use the table when you have succeeded to put it as less than. Now let's use Excel. So we are going to use the same idea. If it is greater than, take the opposite. If it was negative, take the positive. If it was positive, take the negative. Does that work? If you ask your question is about greater than, use Excel with 1.24 instead of negative 1.2. That's what I do. Or another way to think about it, what you get by negative 1 with negative 1.24 subtracted from 1. I don't want to say many things at the same time. If you like, remember that if it is greater than, you switch from negative to positive or positive to negative. Because look at what that means. Suppose this is negative 1.24. Then exactly at the same level here, because of symmetry, you will have 1.24. Do you see that this tail is the same as this tail? That is what I am trying to explain. If we want greater than negative 1.24, which is that top, is the same as less than 1.24. Either you think about it as switching negative to positive or positive to negative, or you subtract 1, because the total area under the curve is always 1. So we will do equal to normal, and we have 1.24. Using Excel, that's what you will get. Now I'm thinking that you can do, if you have this, I will skip this one. If you have this, the lower value is negative 1.34 and the upper value is 1.16. Negative 1.34. So we are going to say that the probability that we are having A less than Z less than B is equal to probability that Z is less than B minus probability that Z is less than B. So with the table, you need to make this. With the calculator, this is the lower value, this is the upper value. You just do this, comma that for your interval. For Excel, you will do this separately, do that, and subtract. So that is where Excel is need a little bit more thinking. So we are going to do that. Those with calculator, you should be done. Those with Excel, you will do normal. And we do the top first, 1.16. Make sure you choose normal S. If you don't choose S, it will ask you for the mean. Put 0, standard deviation 1. And then equals to normal. This doesn't take time. Negative 1.34. Cumulative. Then you do upper part minus lower part. You get the answer. If you were to use the table, you are going to do the same thing, because table only give the left. Excel only give the left. So you need to remember how to find the left for each of them. Okay, the last thing before we go is that when you will be doing your homework, they will ask you for the inverse normal. In each of these questions, for example, here they give you find the probability that Z is less than -1. Now they can ask you if the probability that Z is less than A is something, what was that Z? That is, I can say, what is Z, so that the probability that Z is less than or equal to A is 0.226, for example. What is A, so that the area to the left of A is 0.226. Let me quickly do that on the table. I'm looking for the normal table quickly. What I'm going to do is look for 0.226 as probability. I go to the negative because less than 0.5, it should be negative. 0.22, I'm here 21. This is 22, 223, 226. So this guy is the one. You see, 226. 226 is here. You see what I'm doing? That is the probability. What is the Z? I come back here, negative 0.7, and I go up there, and I will count. Negative 0.75. You see what I've done? You don't really need to understand this one, but I want you to see what it is, okay? Now use your calculator for those who are using calculator, and let's use Excel at the same time. With your calculator, second function, distribution, the third option is inverse normal distribution. Excel equal to, start with normal, and then normal inverse. Use normal standard inverse. Normal standard inverse. And then type the area, 0.226. With your calculator, type that area, 0.226. This is easy if it is the area to the left. If it is area to the left, no problem. Some people have more sophisticated calculator that will ask you, is it left or right area? So calculator, most of the calculator is only dealing with area to the left. If it is area to the right, remember that if you have area to the right, this very number, the area to the left of it is 1 minus the area to the right. So if I tell you what is Z, so that the area to the right is, subtract that area for 1 to get area to the left, and use either your calculator or Excel, area to the left. Okay, so we are done with 6.2. We are going to continue. Do your homework. Do your homework. We are going to continue with 6.2. The difference with 6.3, between 6.2 and 6.3, is now you have the mean and the standard deviation. For those of you using calculator, you will have to put the mean different from 0 and the standard deviation. And we are doing with 6.3. And we are going to do that on Tuesday.